In this video, we're going to do some examples of determining whether or not certain phrases are statements. So recall that a statement is either a sentence or a mathematical expression that is either definitely true or definitely false, but not both. Here are 10 examples below of phrases and mathematical expressions and sentences. So for each of these, determine whether or not it is a statement. After that, if it is a statement, label it true or false if possible. And if it is not a statement, then edit the phrase to turn it into a statement. So try this with the 10 examples below. I encourage you to pause, maybe grab some paper or whatever. Try these out, and then I will go through them one by one. Okay, the first expression or the first sentence says that the natural numbers is an element of the set of integers, that the set of natural numbers is an element of the set of integers. This is a statement. It is either definitely true or definitely false. This one happens to be false. It's false because while it is true that the natural numbers are a subset of the integers, the natural numbers are the positive integers. So every natural number is also an integer, but it is not true that the set of natural numbers itself is a single element of the integers. So it is a statement, it is false. This version of it, if we correct it, this would be true. Next one, x plus 1 equals 24. Well, this depends on what x is, right? So if x is 23, then this is a true statement, then this mathematical equation is true. And if x equals, say, 0, then this mathematical expression is false. And so that means that this equation is not a statement because it depends on x. So this is not a statement. This depends on the value of x, depends on x, and therefore this is called also an open sentence. Depends on some variables within it. 3, if x is an integer multiple of 10, then x is even. Let's see. So if x is an integer multiple of 10, that means like x equals 10 times n for some n in the integers. Is x necessarily even? Yes, that would imply that x was equal to, well, 10n could be written as 2 times 5n, where 5n is in the integers. And so that tells us that, yeah, x would be an integer multiple of 2. If something's an integer multiple of 2, it's even. So this would tell us that x is even. So in other words, anytime that x is an integer multiple of 10, anytime the if part is true, the then part must also be satisfied. And so this overall is a true statement. Next, if n is a prime number, then n is odd. Well, let's see. If n is 3, then yeah, when n is prime, here n is prime and n is odd. But if n is 2, that's false. 2 is an even number, it is not an odd number. So because there are some situations in which this sentence is false, that means that while this is a statement. Next, if n is a prime number, then n is odd. Okay, so in general, an if P then Q statement, well, this is always going to be a statement. And so this is always a statement because it's true if P always implies Q. So in other words, it's true if every time P is true, then Q is also true. And it's false if there's ever a situation where P is true but Q is false. So false if P true, Q false ever occurs. Why is that? So what this statement is saying is that if n is a prime number, then n is odd. anytime that n is a prime number, n must be odd. So if that is ever false, then the overall statement is going to be false. In this case, let's say, n equals 3 is both prime and odd, but n equals 2 is prime and not odd, right? And so that means that this is a false statement. It is a statement. It is either true or false. Any if-then statement or any if-then sentence will be a statement. And it is false if the if piece does not always imply the then piece. Next, we have the sentence, for any set A, the empty set is always an element of A. This is a statement. And again, anytime you have something of the form for any something, like for all or for any, that's always going to be a statement. And again, if it's ever false, then the entire statement is false. And if it is always true, then the entire statement is true. So this is a statement, and this particular statement is false because while it is true that for any set A, the empty set is always a subset of A, it is not always true that the empty set is an element of A. So this is false. For example, like if A was the set containing just the element 1, then the empty set is not an element of A, but it would always be true that the empty set is a subset of A. So this would be a way to edit the statement to make it true. 6, for any set B, B is a subset of itself. This is a true statement about sets. 7, 2 is a subset of the integers. This is a statement, first of all. So it's a statement, and it is false because 2 is an element of the integers, but is not a subset of the integers. So 2 is an element of the integers. We could also write that the set containing 2 is a subset of the integers. So this would be true, but this as written is false. 2 by itself as an element is not a set. 8, the collection of ordered pairs, or the set of ordered pairs 3, 6, 2, 7, negative 3, 18 is a subset of the natural numbers cross the natural numbers. Well, that's almost true. The only issue is that negative 3 is not an element of the natural numbers. And so this ordered pair is not an element of the natural numbers, and therefore this entire set is not a subset of the natural numbers cross the natural numbers. So this is a statement, and it is false. If we wanted to edit the statement to make it true, there's different ways we could do that. We could do, the same collection of elements 2, 7, negative 3, 18. That would be a subset, for example, of the integers cross the natural numbers, because negative 3 is an integer. Everything else in there is a natural number. Next, Ernest Hemingway went ice skating every Saturday during the year of 1943. Well, probably we don't know whether this is true. In fact, I just made it up, so most likely it isn't true, but technically it could be possible, right? So we don't know whether or not this is true or false, but regardless, this is a statement. It is either true or it is false. We don't know which it is, but either Ernest Hemingway did go ice skating every Saturday during the year of 1943, or he did not. So this is a statement. We don't know whether it's true or false. So not knowing whether it's true or false does not prevent it from being a statement. Just as long as it either must be true or must be false, it is a statement. Next, every even integer greater than 2 is a sum of 2 prime numbers. So if we look at this and we say, well, yeah, this is a statement. Again, this is sort of this categorical statement. Like either it's true that every even integer greater than 2 is a sum of 2 prime numbers, or it is not true, and therefore it is a statement. And we could say to ourselves, is this true or false? And, if we wanted to sort of start thinking about it, we could say, okay, every even integer greater than 2, 4 would be the first one like that. Well, that's equal to 2 plus 2. 6, that's equal to 3 plus 3. Those are both primes again. 8, that's equal to 5 plus 3. Yeah, those are both primes. 10, that's equal to 3 plus 7. It's also equal to 5 plus 3. Sorry, 5 plus 5. And so on. And so you could say to yourself, okay, yeah, it's looking like that might be true. Well, in fact, this right here is called the Goldbach conjecture. And no one knows whether it is true. So no one knows, or if they're keeping a very big secret that they could become mathematically famous for revealing. So no one knows whether this is true or false. This is a conjecture that's been open for hundreds of years, and many strong mathematicians have tried to prove that it is true. Many people have also written have written computer programs to show that it's true for the first, hundreds of millions of even integers. So if you did this, you'd be busy for quite a while. But no one has been able to definitively prove either that it is true always or find a counterexample. And maybe sometime in our lifetimes, someone will prove or disprove this conjecture. But as of now, nobody knows whether it is true or false. However, even though we don't know whether it's true or false, it is still a statement. Either it is the case that every even integer greater than 2 is a sum of 2 primes, or there are some even integers for which they are not the sum of 2 primes.